Okay, so we are finding the log of 4.59. I'll repeat this for recording, 4.59. So we get out our log tables. So we look for 4.5, it is here. Now we go to the column of 9. The columns are up here. So we move down until we reach where we have 4.5. So it is here. And this is 6, it is 0.6618. It is point. So you can see here, the first column here, they are showing you that normally these numbers have a point on them. I don't know whether you can see those dots there, a point on them. So it means that all these numbers are in the same way, they have a point on them. So this is also 0.6618. So write it as 6618. Kofita. All right. So so we have also changed that one into logarithm. Now, the next thing is this. Let me just put it here like this. Okay, the next thing is this now. Since this was a multiplication for these numerators, so if it is a multiplication, then we are going to just add the logs and we get the final answer of here in terms of log. So since it is a multiplication here, now we are going to add their logs. So we add here. And when we add, this is multiplication, we add. If it is division, we subtract. So for the numerators here, it was multiplication, so we are going to add this. So 8 plus 2 is 10. I write 0, carry 1. 1 plus 1 is 2. 9 plus 6 is 15. 5, carry 1. 6 plus 6, that is 12, plus 1, 13, right, 3, carry 1. And then you have 1 plus 3. 1 plus 2 is 3. Then minus 2, because this is negative 2. So minus 2, you remain with 1. So you have 1 point. So you have 1.3520 after addition. Now you go to the next one, because the next one comes after this. The next one is 1.6. Come and write it here, 1.6. Then also standardize it, write 1.6. Let me ask, what is the standard form of this? Who can give me what's the standard form of this? Of 1.6? Who knows? Put up your hand if you know. What is the standard form of 1.6?
It's 1.6.
Yes, Esther. Esther.
Yes, teacher.
What's the standard form
it's
of
1.6 times 10 to the power 0.
Correct. 1.6 times 10 to the power 0. Okay. So even this power which I've got here, which is 0, come and write it where? Write it there. Point. Then you look for the log of 1.6. Go back to the log tables and look for 1.6. 1.6. So this is 1.6. And if it doesn't have any other digit, you go to 1.60. So it is only 1.6, but you go to 1.60 because it doesn't have any other digit. Okay, so you have, let me zoom in there and you see. So you have 0.2041. 0.2041. Okay. So write it as 0.2041. That's what we have. Good. So we have that. We have not finished. Okay, so from there, what we are going to do is we are going to now do what we call the subtraction. From this, what we have got, we are going to subtract. Why do we subtract? We subtract because the answer of this is divided by this. So the answer that we got, sorry, the answer that we got here, which is 1.3520, it comes from this, and this was the multiplication, and we added to get this. Now, this is divided by this. This is divided by this. So this one, we are going now to subtract this minus this, because here there is division. Okay, I think you have got that one very well. Now, when we subtract, we borrow a 1 from here, and we put it here. It becomes 10 here, remaining with 1. So 10 minus 1 is 9. And here we have 1 now. So we borrow from 1, here have 11. Here remains 4. So 11 minus 4, what do you get? 11 minus 4, you get? You get 7. I think you get 7. Okay. And then you have 4. 4 minus 0, you get 4. 3 minus 2, you get 1. And then 1 minus 0, you get 1. Something like that. Okay. So you have 1.1479 as your your final log after subtraction. Now, in this second column, now we go back, we turn this side because we have to find the answer, not in logs, but in a number. So now we go back and we write it in standard form. This. So for us to find the standard form of this, there are two things that we are going to do. The first thing is this, that this number which is here, as you saw that this number these numbers which were here came from powers. Okay, so even this number which is here is of a power, and that is a power, and that number is a power of what? Of 10. So we shall have here we shall have a number which we are going to put here, but we know that this one which is here is also a power, and it is a power of what? Of 10. So here we have 10 to the power what? 10 to the power 1, something like that. So this one is done, which is here. The same way how we saw that this 2 which is here came from a power here. So it means that even this one which is here is a power of what? Of 10, which should be here. Okay. Now, the other thing is that we have to look at 1479. So we are not going to treat, we are going to treat this one as point, not 1 point, but 0.4.1479. So we are going to use, we are going to remove the 1, and we shall consider as 0.1479. Because the one we have already removed it, it is already here. So we are going to remain with 0.1479. And we are going to find the antilog. So we are going to look for the antilog of that. Antilog. What is the antilog? Antilog of 0.1479. What is the antilog of that? So we are changing from log to the antilog. So that's where we get out our antilog tables. Okay. So this is logarithm here. We go to antilog. And under antilog, we are going to look for 0.1479. 0.1479. So when you look at the antilog here, if I may zoom in very well, I want us to keep this here and also to look at this. So when you see the antilog is giving us here 2 decimal places here. So that means that we have 0.00, 0.03, 0.01, 1.21, 2.1. So there are only 2 decimal places here, 2 decimal places in the column of X. So it means that we are going to first look for 0.14, 0.1 what? 4 first. That's what we are going to look for first. That's the first thing. So in this column, we look for 0.14, and it's not very far. 0.14 is here. Okay, it is here. So that's the first thing we have seen. 0.14 is there. Now, I zoom in there for you to see very well. 0.14 is there. Now we go to 7. Sumuluzuali. the key, the key. Now, after here, this is 0.14, okay? Now, this is that 1.4. So we go to the column of 7. So this is where we have columns up here. So we have columns, and 7 is here. So we look for that value that corresponds to 0.14. So it is here, it is, now this one is, I want you to look at this first digit, which is here. I want you to, let me zoom in there for you. I want you to see. Now you see there are points which are here, points. Other log tables do not show this, but there are points in between here. Eh? So it means that this is 1.380. So even these ones, it means that they have 1.384, 1.390, 1.393, 1 point like that. So even this one, which is here, now if I zoom out a bit for you to see clearly. So this one, which is here, it is also 1.403 for the column of 7 here. So for this one of 7 here, now this one of 7, it is giving us 1 point, the way I've read it from here, 1.403, okay? 1 point, because our number is 0.147. So I finished to find 0.14. Now we go to the column of 7, and under the column of 7, we have 1.40, 1.403. Okay. So I'll come here and I write, I'm getting 1.403. That is under 7. That's what I'm getting. Now I'm left with the column of 9. Okay, I'm left with the column of 9. So I'll go to the column of 9, and also I have to find the value which is there under the column of what? Under the column of 9. Okay, so we go back. So I'll zoom out slightly a bit for you to see the overview here. So this is 1.4, and I want to go to the column of 9. Now 9, we shall get it from this side where there is a difference. Why? Because this is another decimal place. Actually, it is the 4th decimal place. So it means that now I'll go to the part where we have differences. So I'll finish this part. First, I looked at 1.4 from the X. Now I looked for 7 along this column here, using these values which are here. I looked for 7 here, and I got to the value. Now the next digit, which is 9, I'm going to use this other column here where I have differences. So differences and add. So differences, but you do the addition. So I look for the number which is there, and the number which is there under 9 in this same row of 1.4 is 3. You can see there. If you can't see very well, I can show you that that number is 3. So that number is 3, is down, which is here. So I'm going to write that 3 as, I write it to 3 decimal places. So I write that 3 here, but the rest here, I fill them with zeros and I put a point. So that number which I obtained is 3 here. I write it 3, but I fill these other places. Sandra, what I'm saying is that I've obtained 3. Yeah? You saw how I obtained 3.
Yes.
So after getting that 3, let's say, okay, let me say that 3 multiplied by 0.001, such that you get 0.003. But in a simplest way, you just write the 3 here, and then you fill these other places with zeros. You have to know that this one should be to only 3 decimal places.
Yes.
So afterwards, you come and add. Because there they were saying difference, but in brackets they were saying what? Add. I can show you back. It is differences, but they are saying, you do what? You add.
We add.
Add. Okay. So we are going to add these two, such that we get the antilog of 0.1479. So when you add this to this, we get 6. Add here, we get 0. Add here, we get 4. And here we get 1. Okay? That's what we get after addition. Okay, so now that number you have obtained after addition is what you write here. And we have it as 1.406, like that. Now, from here, you can just use your calculator and see what do you get if you multiply this by 10 to the power 1. So I can just show you there. So I have 1.406 times 10 to the power 1, and I'll get 14.06. I have 14.06, and that is our correct answer. So when someone, so some people, like the teacher did this and just showed us that this is the answer and everything was right. So people passed that question. That was question number 3. The teacher Maya and Sherry, they passed it very well. And that was the correct answer as 14.06. So you can go back and prove yourself. If I multiply that, if I have 490, then times 0.0459, and then I divide it by 1.6. So you can see it is 14.056, but if I round off here to 2 decimal places, I get 14.06. So it means that our answer is correct. It's correct. Okay, so for the review, you
Excuse
take
me, sir.
Yes, Wilma. Is it Wilma?
How do you get the antilog using a calculator?
Now, I don't want to tell you how to use a calculator because the examiners will see, and that's why they told you to use using tables. So in most cases, students use a calculator, and you know that the calculator will give you 4 decimal places, and sometimes people may forget to round off, others do not even round off at all.
What if you don't have a log table?
What if you don't have a log table?
Yeah.
People want to use calculators. For me, what I see, a log table is easier than even a calculator. Okay, I don't know what you would prefer, but a log table is far, far better because it gives
Okay.
you the exact value according to what the question is telling you. So they're telling you using tables. Now, when you use a calculator, you are likely to make a mistake with rounding off, and that's when the examiner can get you. Or you may write the answer to 4 decimal places there, and then the examiner will get you and say this one really used the calculator.
Okay.
So, but the log table will give you exactly what the examiner has in his guide. Now, you don't have to write all this. This is takataka circus here. But what is very important is what is in this table. These are very easy questions. Now, if you have understood this question, you can go and check in the books that we use for learning, USA, and you do some numbers which are there. You practice and make sure that you do such questions which are similar to this, and you have that topic in your hands. Hurry, tujende maso. So that's how the question was supposed to be done. So we can go to question number 4. Question number 4, it is telling you to factorize x squared minus 2x, then minus 35. First, factorize that. So we can prime factorize 35, and you see. So I can decide to divide 35 by 5. Okay, you can prime factorize. I think the easiest thing is to list the factors of 35. That is the best thing. Factors of 35. So I have 1, I have 5, I have 7, and I have 35. I think those are the factors. Do you have any other? Do you have any other? Okay, so those are the factors of 35. Now, of these factors, you should know that now, here I have got a sum of -2, and I have a product of -35. Okay, so with these two factors, you should know that which two numbers should you multiply and you get 35, and should you add and get -2? Which numbers should you multiply and get 35? So I have 5 and what? 5 and 7. This one I get 35. But because our 35 is negative, I'll first leave positive here. Then I go to the sum, and I have, how do I subtract 5 and 7 for me to have -2? If I have -2 and I have 5, 7, what should I do? So it means that if I have 7, if 7 is negative, then plus 5, then I'll get -2. So it means that my 7 should be negative and my 5 should be positive. So here I'll put a -7 and I'll have -35. So there are two digits now, -7 and positive what? Positive 5. I don't know who's calling me on WhatsApp. People should be serious. Now, after doing this, since my 2x, this -2x, I'm going to express it in terms of -7 and also positive 5. So I write it as x squared. So where I have this, I'm going to write it as -7x, then plus 5x. Of course, -7x plus 5x, it takes me back to -2x. Okay? Takes me back to -2x. Then I'll bring now 35 minus 35. So this was Takataka Circus, this one here. So this is how you're supposed to do. So now here, I'm going to group them. So I group this one and this one, then this one and that together. And then I'm going to find the common item here, which is x. I take it out from this group here. X, I take it out, and I'll have, if I move x here, I remain with x, then minus, if I remove x here, I remain with 7, then plus. Okay, so what is common here is going to be 5. Why? Because 35 can be expressed as 5 times 7. So I put 5 out. If I remove 5 from here, I'll get x minus. Now here I have something like 5 times 7. That's what is here. 5 times 7 is 35. So if I remove 5 from here, I'll remain with 7. In other words, this should be the same as that. That's what you have to do. Then I'll join this with this one, and I'll get x plus 5, then into x minus 7. So that is the factorization of x squared minus 2x minus 35 as x plus 5, then into x minus 7. Okay. Now, hence, they're telling you hence. When they say this word hence, it means that use what you have obtained here to find x squared minus 2x minus 35 equals to 0. Use this to find the value of x. Use this that you have obtained. If they say hence or otherwise, then it means that you may use this or you may use another alternative, okay? But here they have said hence, solve the equation, this. So it means that you have to use this. So to use this, remember that this came from here, okay? So where we have this, I'm going to write at x plus 5 into x minus 7, and I equate this to 0, like that. So it means that this bracket is equal to 0, and also this bracket is also equal to 0. So I have x plus 5 equal to 0, or x minus 7 equal to what? 0. So I'll get my x as negative 5, and my x shall be 7. And have your full marks of that question. That's how you're supposed to do it. Okay, time is on our neck. We go to number 5. If you have not understood, you can ask a question, but let us go to number 5. Okay, number 5, they are saying that k equals to negative 1, 4, and m equals to 3, negative 2. Okay, then they are saying that find k plus m. Now these are vectors, and this was very easy. So negative 1, 4 plus 3, negative 2, like that. Such that I get, now I add this plus this plus this. Negative 1 plus 3, I get 2, and then 4 minus 2. Now it is only one person instead of, I think that was the teacher. That was question number 5, yes. Instead of adding here, made this one to be positive 2. So here I have to get also 2. Because 4 minus 2, you get 2. So that is k plus m. And then they are saying that r, Roman number 2, they are saying that r, find the magnitude of r. But they are saying that r is k plus what? K plus m. So in other words, they are telling you to find the magnitude of k plus what? K plus m. I was happy with Sandra. Sandra passed that question very well. So it means that here, they are telling you to find the magnitude of this. How do you find the magnitude of this? The magnitude is given by x squared plus y what? Plus y squared. Where this value stands for x and this one stands for what? Stands for y. So substitute there and put 2 squared plus 2 squared. Okay, and you get the root of 4 plus 4. So you get the root of what? 8. And the square root of 8, when you use your calculator there, it's around 2. So you have 2.83 as your answer. Okay. That's how it was supposed to be done. Now, question 6. We have 7 minutes. Question 6, they are saying that Mary lives 5/6 of a kilometer from her school, Okay, we know that 1 kilometer is equivalent to 1,000 what? Meters. Okay, 1,000 meters. So it means that if Mary is 5/6 of a kilometer, so of 1,000, so we can get it in terms of meters, and we shall see that Mary is 5 divided by 6 times 1,000. So she's living 8, can put that one in decimal, in fractions, 833 and a third meters. That's her distance from the school. Okay, they are saying that Jenny's home is half the distance, is half this distance. So Jenny's home is half this distance from the school. Then they're asking how far away from the school does Jenny live? Okay. So this one, if you may draw, if this is the school here, okay, and this is where Mary is. So Jane is just here halfway. Jane is halfway. So if for Mary it is 88833 and a third meters, then for Jane it's going to be a half of 833 and a what? And a third, isn't it? From the what? From the school. So it means that Jenny's distance is going to be a half of 833 and a third meters from where? From the school. So that answer, if you multiply it times a third, that means times a half, you get 416.67 meters. And that was Jenny's distance. That's a simple question. It was just checking your reasoning a bit, but it was a simple question. Okay, so let us look at this other question, which is here. Question number 7. And with question number 7, this is I think I'll end with this question. I wanted to finish section A. I don't know whether teacher Isaac will be there, but let us see number 7. Number 7, it is a question that required you to must have done some little research about enlargement and similarities. So they are saying that two triangles are similar. So the base of one is 16. So I will draw the first one, which has a bigger base there. Its base is 16. Okay, 16 centimeters. And then the other one, its base is 12. So it is quite small compared to the first one. Okay. This one, its base is 12 centimeters. Okay. So they are saying that the area of the first one is, let me call it A1, is 144 centimeters squared. What is the area of A2? Now, other people are saying area of A1 over area of A2 is equal to 16 over this. But you can't use this. You can't use this A1 over A2 equals to 16 over 12. Why? Because this is area here, and this is length. Okay, you can't use them. So this is area, this is length. So in other words, here you have to get the linear scale factor. There's what we call linear scale factor. You have to first get the linear scale factor. After getting the linear scale factor, then you can get the area scale factor. Then you can find the areas. So the first thing is you had to first get the linear scale factor. LSF, the linear scale factor. To get the linear scale factor, you can say maybe the base of the big, if I call this one capital B and this one small b. So the length of the bigger base over the smaller what? Over the smaller base. Such that you have 16 out of 12. And 16, you simplify that, 16 divided by 12, you get 4 out of what? 4 out of 3. So that is the linear scale factor. That's the linear scale factor. Now, after getting the linear scale factor, you find the area scale factor. So the area scale factor, ASF, is equal to the linear scale factor squared. So you square the linear scale factor for you to find the area scale factor. The same way how you know that square, you have to square area. It has like centimeters squared. You can see it in the question here, centimeters squared. So it means that also the linear scale factor has to be squared for you to get the area scale factor. So 4 out of 3, and then you square it, and you have 4 squared over 3 squared, something like that. And you have 16 out of 9. So you simplify 16 divided by 9. If you simplify that, yeah, you mean with the same thing, 16 out of 9. Okay? 16 out of 9. So that is the area scale factor. Okay. Now, if you want to get to the area of the smaller one, that's when you come and say now, the area of the big, area of big out of the area of the what? Of small.